I think the skin is hello. So we will start today's class within a few minutes. I think the skin is visible to all of you. Okay, we'll start today's session. First of all, let me introduce myself. Um, so I am Niloy, a PhD scholar from IIT Bhubaneswar, and I welcome you all to this live interacting session. So today is our last live interacting session where I will summarize all the topics or all the important aspect that has been explained in the last 12 weeks live interacting session. So I hope that all of you have already gone through this course at least once. So if you are facing any question regarding this, today's session is for this reason. So you just raise your concern. Okay. Apart from this, I will summarize some of the previous concept which I feel is important for your exam point of view. And also I would suggest you to please follow these courses again to revise this course or this lecture that has been provided by Professor Subhashish Datta. So I hope that that will be beneficial for you. Also, you can find the recording of this live interacting session for the last 12 classes that has been already uploaded in the corresponding YouTube channel, and the link has been shared with you from this NPTEL site. And also the PPT or this notes has been shared with you in a Google Drive. The link is also provided with you from this NPTEL site, right? So let us start this summary session. So as you have already completed this whole session, so why now you got to understand why this courses is important, how fluid mechanics helps you in your engineering perspective or in real life problem solution. Like you have studied about a lot of concept. I can start from this surface tension concept of the capillary action, Bernoulli's equation, Pascal's law, and even this Navier-Stokes equation, open channel flow, pipe flow, and all these things, losses in a pipe. These all these are important concepts that you can utilize for your research purpose or even in in solving some problem. Like you are facing any problem, you are planning to design an experimental setup. For this fundamental idea, you need to know how much this length should be kept and how much um, to achieve this much of Reynolds number, what is required, and the important aspect of this fraud number, and all these thing is quite essential. So even some of you may be interested in doing some aerodynamic problem. There also this Bernoulli's equation or this how this pressure variation helps. And in civil engineer, like if I talk about this Burj Khalifa, the design of this Burj Khalifa, how this drift force and lift force acts there, you can go through this YouTube and find this thing quite interesting for your for these courses. So I hope that to this 12 like 12-week classes you have gone through this thing, and please try to implement this through a real problem, or anywhere you just show a phenomena, you just try to recall why this thing is happening, why these types of bending is happening, or why the air is moving like this way, not that way. So you have to ask question to yourself so that you will get this answer, and try to implement your concept in this, so that will definitely help. And also, as your exam is approaching, please, on the November first week of November, so time is not that much left, so better you just revise and accordingly go for this exam. Definitely this, I hope that these courses will definitely help you to enrich your knowledge. Okay. So in the last week that we have discussed about about the open channel flow, which is our last module for this semester, and how the Reynolds number varies for this open channel flow and this pipe flow. That thing has been analyzed, right? So say for this open channel flow, the if the Reynolds number is less than 500, then it's a laminar. But whereas in case of if I talk about this pipe flow, if the Reynolds number, in that case the Reynolds number should be less than 2000, then it is laminar. Whereas in case of open channel flow, if the Reynolds number is less than 2000, that is 500 to 2000, that is transition. It is not laminar. In the whole range of 2000, up only up to 500 it is laminar. Like that thing you have already, I have already give you this information in the earlier classes. So if you miss the earlier classes, you can uh, have this recorded lesson and just follow this thing. This will help. Also some of the important on the fundamental numerical problem we have solved, so that will definitely benefit you. So in this week, in the today's classes, we will discuss about this summary of what we have studied in this last or the previous live sessions. So coming, what I will do, I will take an important question from each of this module, and we will recap you this fundamental that will help you to remind what has been taught in the classes or that thing, right? So in the first, if I talk about this first class, what we have studied in the first class, can anyone recall? So in the first class, we have discussed about this specific volume, right? So before moving into this topic in the module 1, I just recap this thing module 1, what we have discussed. In the module 1, we have discussed about these various properties of fluid, right? What are the properties of the fluid? Uh, say the specific volume, or all these things we have studied. In the also we have studied about this viscous force, non-viscous force, what is incompressible, compressible flow, that thing we have studied. So all these important properties we have studied. And apart from this, what is bulk modulus, and I think this bulk modulus also I have given you this knowledge about this thing. So and also this droplet problem we have studied. Please go through this droplet problem. That means this pressure inside a droplet, or this surface tension. So that thing you have also studied, right? So surface tension is quite important. Why? What is the another important thing? If someone tells you about this surface tension, why surface tension? What is surface tension? Say, so the surface tension basically, the surface tension. Why the surface tension is occur? This is because of this cohesion between the liquid particle at the surface. Say this is a fluid body and there is a liquid. So the surface tension is because of this cohesion force between two particles. Okay. Whereas this capillary, and you have also heard this word capillary. For this capillary, both this action is required. One is cohesion and another is adhesion. So what is cohesion? Cohesion is among the cohesion is the force among two similar particles, whereas adhesion is between two different particles. That is, for capillary action, one is against the surface and another against the liquid. So these two particles will helps in this capillary action. So both adhesive and the cohesive force acts in case of capillary, whereas in surface tension only cohesive force act. So that thing we have studied. Apart from this, also please remember this SI unit of all these thing, Newtonian fluid. I think that you have studied, and also this capillary problem. So this based on this capillary rise problem, I am giving you a question. Please try to solve this one. I am giving you 2 minutes time for this one, and after that I will solve this one for you. So can you please try to answer? I am giving you 1 more minute. So one. Yes, so I have received an answer which is option C. Okay, I am recapping this thing for you and see whether this answer is correct or not. So first you need to know what is capillary rise. Capillary rise, why capillary rise occur? So it occur because of the balance between the surface tension force and the weight of the liquid current inside a small diameter tube. Say this is a tube. Okay. So you will observe certain phenomena where the liquid sticks with this surface from both along this glass, right? So that is capillary rise action, and it is because of these particles. The glass has some particle and the liquid has some particle. So two separate particles are there. That means there is adhesive force, and also in the liquid similar particles are there. That means there is cohesive force. So as both these forces are present, so certain phenomena is happening there, right? So for the capillary action, what will happen? So you have to check whether this liquid, weight of this liquid on the surface and the surface tension force should be same. Because surface tension force. So what basically is the weight of the liquid? So weight of the liquid is a mass into gravity. You know what is the mass here? So that will be rho into volume. So this in case of this here, so volume, for this volume we need this area into this height, capillary height. So actually exactly if I draw this thing, this portion, it will looks like this, right? And that line, if you observe from the top, it's a circular. So having, say I take this diameter as d and height as hc. So volume is pi by 4 d square, that is the area of the base into height. Height is ac. So that means this is the mass, right? Mass is equal to rho into volume, density into volume. So weight of the weight means here mass into gravity. So I can write into g, right? And these, and talking about the surface tension force. So the surface tension is represented as sigma. So surface tension always acts on the perimeter. So surface tension force means surface tension into perimeter. What will be the perimeter here? Say C. And another thing is that it will always act at that direction, right? So what is the tendency of this fluid? So the tendency is to deviate in that direction. So it will have two components, one in this direction and another in this direction, right? So in that direction, so if I consider this capillary rise angle with theta, so what will happen if this is sigma cos theta and this is sigma sin theta, right? So this sigma sin theta say the sigma sin theta is in that direction, and similarly this sigma sin theta is also for throughout this tube it is in outside direction. Say if I take 180 360 point throughout this tube, at each and every point this sigma sin theta will act outward direction. So that means as it is acting in the outer direction from all sides, so it will cancel each other. So we will not take this component, we will only take this component which is sigma cos theta. So that's why not only sigma, it should be sigma cos theta, which is surface tension, not force. Uh, so we know to find out the surface tension force, we have to multiply surface tension into perimeter. What is the perimeter? This perimeter pi into d, right? So you just check here, pi is cancelling out, d 1d is cancelling out. So what I can write? I can write AC is 4 will goes upward, 4 sigma cos theta by rho g, and d will come below. So that is the formula of the capillary rise, right? So you have to remember, either you remember this formula or you have to remember this derivation. So also please recall this derivation, because that thing can also be asked in the exam, right? So this is our formula. So what is given in this question? 1 meter diameter. So rise in a 1 meter tube diameter. So in one cases this D1 is given as 1 mm and capillary rise is 3 centimeter. So AC1 is given as 3 centimeter. So we have to convert it into either mm or 1 mm into centimeter. So that thing you have to convert. So you are asked height of the capillary rise of the water in a zero point 0.2 mm tube diameter. So he say, so in the question says that if D2 is 0.2 mm, then what is AC2? So that is the question, right? So here water. So for water, that sigma is same for water. If two other fluid is there, then it will vary. G is same, density is same, theta is same. So for water, which one is variable? Only diameter is variable. I can write proportional to 1 by d. Yes or no? Because for water, because it's for a single fluid, this sigma, density, theta and all these things are equal. The theta is the contact angle. The contact angle and all these things are equal. So I can write as from this formulation. So I'm writing with red color. So AC is inversely proportional to this one. So I have to find H21. So I can write now H this one, as it is inversely proportional. So their one should be D2 and their one should be D1. So what is D1? D1 is 1. D2 is zero point 0.2. So that means 5, which is 5. So AC2 is 5 into AC1. What is AC1? It is 3 centimeter. So that is in mm. Say it is given answer in mm. So I have to convert it into, it is 30 mm. So 5 into 30, which is 150 mm. So the correct answer is option C. So whether you understand this concept, so please let me know through this chat box whether any confusion from this module, first module, or anything confusion, or you can uh, on your mic and ask you me your doubt. So I will be give you 1 minute time to check and understand this thing and let me know. And after that I will move to next module to recap this next module. So what should be the changes that can be asked in the question in the exam? So question like say in the exam it can be asked that for two fluid, though in that case for same diameter, say in a capillary rise of water in 1 mm diameter tube is this mass. So then they can ask what is the capillary rise of mercury in the same tube diameter. In that case they will give the density and this contact angle and all these parameters they will give. You just have to find out this, but for this you need to remember this formula. That is quite essential. This formula AC is 4 sigma cos theta by rho GD. Any confusion? Okay. So I feel that you don't have any confusion. So I am moving to this next question. So this is regarding one of the important question from the second modulus, which is this concept of hydrostatic force. So I just give you a little brief about this module. What have you studied in this module? Okay, just a minute. So in this second module, we have studied about this concept of fluid hydrostatic. Na? We have studied about module 2, pressure and hydrostatic force. Also buoyancy, matter center, and all these things we have studied. This thing we have studied. So the first thing in this chapter, what we have recall is that Archimedes principle we have studied. What is basically this Archimedes principle is? So it's basically say a floating body. What happens in a floating body? If a floating body is there, it will displace its own weight in the fluid in which it floats, right? Say if a body is floating, so if it has certain weight, say W, so what will happen, it will displace W liquid from its place. So next is that if the body is immersed, for the floating body I am talking about, also what happen if for the immersed body, so in that immersed body, uh, so the total weight of the body will taken into consideration. But in case of a floating or partially submerged body, you have to take only those weight which up the weight up to which it is submerged. So that area is taken into consideration in that case. So that thing we have also studied. So even hydrodynamics force also we have studied. We have studied about absolute pressure, atmospheric pressure or gauge pressure, right? So absolute pressure means this atmospheric pressure plus gauge pressure. You can recall this thing. Also we have studied about this Pascal law. So what basically is the Pascal law? So the Pascal law basically state at any point in a fluid or maybe it is static fluid, the pressure is same in all direction. So if you take any point in a fluid, so the question is that the thing is that like if you take in that point whatever will be the pressure at that point, all the point in this line should have the horizontal line should have the same pressure. That is the fundamental that has been taught in this Pascal's law. Okay. So that are the basics, important basic. Apart from this, there are so many things that we have studied, but these are some of the important points which I feel need to recap you. So this is the first question. I am giving you 1 minute time to solve this one. Not 1 minute, 2 minute time. Say here two equal volume are two containers they are talking about the cross section variation in the cross section. One is double, the other is given. So P1 P2 is the pressure exerted at the bottom. So you know pressure is P1 is rho gh, total height of the liquid. So we'll guess the gauge pressure. So that thing you can implement and accordingly you can solve. So for your understanding, let me give this diagram. So this is the diagram. You just try to answer and giving you 2 minutes time for this one. So say it is at height h. So if I have to calculate pressure, what is the pressure at this point atmospheric? It should be zero. We assume this as a reference and it should be zero. So that at point it should be pressure should be 0 plus rho g into h. Please try to solve this one. I am giving you 2 minutes time for this one. So I think I have received an answer. This is option D. Okay, let us see. So see, as I told, the atmospheric pressure, what I have said, this atmospheric pressure is, atmospheric means that a gauge pressure at this point exposed to atmosphere. That means I can consider this gauge pressure as zero. So at the bottom, if I have to take this pressure, if say this is P1, P1 is rho g h, and in that case, for the case 2, P2 is rho g 2h. That means P1 by P2 is this divided by this one. So which is 1 by 2. So the P1 is zero point 0.5 P2. So that means option A and B cannot be answered. So it should be between C and D, right? We're coming to this force. What is force? Force means pressure into area. That is P1 into area. In the first case, area is 2A. It should be 2A, right? So pressure 1 is, if I write, and F2 first, I write the F2. F2 is P2 into A. So if I, in place of P1, I can write this as, no, better, yes. So that means zero point 0.5 P2 into 2A, which is P2 into A. So both F1 and F2 are equal. So F1 is and F2 both are equal. So the correct answer here is option F1 F2 equal. Option C will be the correct answer. I hope that you understand your mistake, both of you. Just a minute. What happened there? So that is the fundamental concept. So I am moving to this next one, next question. So which is from the another module. So this is for from third week's module. So what we have studied in this third module, first let me recap this thing. In the third module, we basically deals with this Reynolds transport theorem, conservation of mass and conservation of momentum, right? What is intensive property and what is extensive property? This thing we have studied. So what is intensive property? Intensive property basically is a property that is independent of the size or the amount of system. So that means, say if I talk about temperature, pressure, density specific that are independent of the size or the amount of a system. Say if you kept 1 liter of water in a vessel, so whatever will be the temperature of the vessel, and if you take one glass from it, the temperature of the liquid will be same. So it is not dependent on the size or the amount of the system. That's why these types of units is known as intensive property. This types of property is known as intensive property. Now if I talk about this extensive property, so this extensive property basically is a property that depends on the size or the amount of the system. So if I talk about this mass of the volume, say again I take the same example of a one bucket. Say this is I take one bucket of water, and after that I take a glass of water from it. So either the volume in both these cases will be equal? No, because it will be changing. That means volume is dependent on the quantity or the size or the amount of the system. That's why they are known as extensive property. Okay, so that is the thing. Also, this Reynolds transport theorem, what basically this thing is. So this is a theorem that basically link or the bridge between the system approach and the control volume approach. So what is system approach and the control volume approach? You remember this thing? So just for you, I'm recapping this thing. Reynolds transport theorem. So basically it incorporates two approach. One is the system approach plus control volume approach. So what is the basic difference between these two approach? So if I talk about the it's like this system approach basically follows a set of fluid particle, whereas this control volume analyze the fluid flow through a defined region in space. Say this is a river, this is a river. You are observing a leaf, or you are observing any ant. Say not a bottle, and a water bottle is flowing in a river, say. So if you are following this water bottle throughout, so you are moving with this water bottle, that means this is known as the system approach. That means you are only studying this bottle. And another approach, the CB approach, is that in the river, say you are only focusing on this region of this river. So whatever is flowing through this region, only as your main focus is only this region. That's why it is known as CB approach. So this Reynolds transport theorem is a such approach. Follows the it follows the fluid particle also, and also a specific a definite region of the space is also analyzed. So both this thing is included in a single concept, and that is known as Reynolds transport theorem. So that thing you also we have studied from this thing. Okay. So what is the basic and equation like continuity equation we have studied fundamental of this continuity equation. So it where from where it comes? It comes from the conservation of mass equation. Continuity equation comes from the conservation of mass. What the conservation of mass equation tell that mass can neither be created nor be destroyed within a closed system. So that thing you have studied. So it's a modified version. It's a little modified version of this mass conservation equation, where it states that the continuity equation states that the mass of a fluid remains constant as it flows through a given volume. So if it's a domain, so a given volume, and whatever is accumulating inside the system, that should be equal. Say a q1 amount of mass is flowing and q2 is coming out, and say q3 is stored in the system. Then these types of, so what I can say that in that cases this q1 is the total flow entering into the system, and either there should be coming out directly. If there is no q2, then q1 and q2 should be same, but as it is something storing, so that That means that Q2, whatever is entering into the system, the full amount is not coming out, something is accumulating in this system. This is basically the fundamental of this continuity equation. What is Q? Q basically is rho A V. Okay. So for water or any specific fluid, the density is same. So I can, in place of this, can I write for a definite fluid, say we know the fluid, so I can write rho A1 V1 is rho A2 V2. That Q2 means, say I am it is moving out that direction. A3 V3. So rho is cancelled out. So we will get A1 V1 is equal to A2 V2 plus A3 V3. Okay. So that is the fundamental concept of this equation of mass conservation equation of the continuity equation. So now using this concept, I think that you will be able to solve this question. So please try to solve this question. I am giving you 2 minutes time for this one. 3 minutes. So please solve this one. So please try to solve this one. Okay, I am just giving you a hint. Say in this system, say in this from 1, this is the inlet pipe, and 2 is the outlet pipe, and also from this 3 another liquid is entering into this system. So from this mass conservation of whatever is entering into this system and whatever is coming, that should be equal. So what is entering this system? So say from 1, that is Q1 is entering this system, and also Q3 is entering this system, that should be equal to Q2. So this one is the mass coming into this system, and this one is the mass going out into this system. So that's why I can write this way. So what is Q? I know that it's water, so I can write A1 B1, right? Q in place of here I can write A1 B1. Okay, just a minute. Sorry, a little bit of mistake I have done here. So actually in the last slide also, this was not actually Q. Yes, the correct option. Someone is answer is, I think, yes, C. Yes, correct answer is C. So check. Actually, it is the concept is not Q in the last slide. Most probably not in this slide. Yes, yes. Here. So that basically is whatever is entering, mass is entering, M1 is entering into the system, plus M3 is entering into the system is equal to M2. This is the total mass in the system should remain constant. This is a mass conservation equation. Okay. So what is M dot? M dot is rho AB. So please remember this. Previously I have made it is not Q. Q is only AB. Q means A into B. Okay. And M means rho AV. Okay. So I can write here rho as diameter is given. So we have to use A1 B1 plus in case of M3 Q is given. So I can write na rho into Q because AB is Q. So rho into Q3, and in place also diameter is given. I can write rho A2 into B2. So rho will be cancelled out and I will get A1 B1 plus Q3 is A2 B2, right? So what is A1? A1 here should be diameter is given. So I can write pi by 4 into diameter is 5 centimeter. I have to convert it into meter. 0.5 square. What is the velocity? Whether the velocity is given here. Pipe velocity is given as 2.2. 2.2. And Q3 is already Q3 is given 0.01 meter cube per second. And area of 2 should be pi by 4 into this diameter is 0.07 square into velocity you do not know, and accordingly all other values are known, only V2 is not known. So you just calculate and accordingly you will get V2 is 3.72. So good Vidisha, you have answered it correctly. Very good. Okay. So that is the concept. So similar types of question can be asked. So up to this is some important concept regarding this third module. The previous one already I have discussed. Now I am moving to this next module, which is this the in the fourth module. Basically the what we have studied about in the fourth module, we have studied about this conservation of momentum equation, Bernoulli's equation. Mainly we deals with this Bernoulli's equation. What is this Bernoulli's equation? I am just giving you a little brief about this Bernoulli's equation, so that will help you. So you need to recall each and every point of this Bernoulli's equation. So Bernoulli's equation basically is an equation of conservation of energy. Please remember this thing because often the question will be asked in this line. So for this Bernoulli's equation, so certain assumptions are there. What are these assumptions of this Bernoulli's equation? First is that it should be a steady flow. Next is that it should be an ideal flow. Third is that it should be irrotational. So this is very important question. Please remember this thing. I hope that or at least a question will definitely come. In viscous flow. Next is that incompressible. Next is flow along streamline. Okay. So these are the main assumptions in this Bernoulli's equation. I think you got it. So say I am talking about to a pipe. Sorry, this is a pipe. So these are two sections of the pipe. This is section 1. This is section 2. Okay. So in this section 1, having different area, different velocity and all this. So in this section, if I know that velocity is v1, area is a1 and all these things are different. Pressure is p1, like, and this one is p2, v2, a2, like that. And also say this point, I'm taking another line. So this is our ground. Say this black line represent ground. So this point, one point. So the distance of this point, one point from here, say this is Z1, and from this point it is say Z2. It is slightly above Z1. So Z1 and Z2. So this continuity equation tells that total head. Total head means total head should be constant. Total head means pressure head plus velocity head plus used what is called potential head or datum head. So what is the pressure head? Pressure head basically is the thing that is stated is that P by rho g plus v square by 2g plus z should be constant. That is the Bernoulli's equation. Okay. So at this 1 and 2 point, first you need to find out the total head at 1 point. So I can write P1 by rho g plus V1 square by 2g plus Z1. This should be equal to at 2 point it should be P2 by rho g plus V2 square by 2g plus Z2. So that will be the concept of this Bernoulli's equation. I think you understand this concept. Definitely a 5 to 6 months question will come on this concept. So please understand this concept quite precisely. If you have any doubt, please raise your concern. Okay. Now you can please try to solve this question. So in this question, what has been asked? What will be the pressure at the narrow end? So a nozzle is there. I think you understand this. Just I am drawing this diagram for you. I am removing all this thing, okay? So a nozzle initial diameter is larger and after that it is reducing to 100. Say here they are given the diameter D1 as 200 mm or D2 D2 is given as 100 mm. All other things are given. So you just have to find out the pressure at the narrow end. That means you have to find out P2. So also another thing is that so the what is given the gauge pressure at the other end of the nozzle is at, so already the pressure is given as 400 kilo Pascal. That means 400 into 10 to the power 3 Pascal. Okay, and also Q is given. What is given? Q is given. So the water is flowing through the nozzle. That means Q is given, or Q1 I can say, or whole Q is given as 40 liter per second. Okay, please solve this thing. So as Q is given, so that means Q means mass flow rate. So from this you can find velocity, because continuity equation we can, from this continuity equation we can write A1 V1 equal to A2 V2. So what is basically A1 V1 or A2 V2, which is basically Q. So from there you can find V1, find V1 and find V2. And after that put it in the Bernoulli's equation and all other values are given. Please find. I am giving you 3 minutes time for this one. And one more thing, listen that convert liter into meter cube. So 1 liter means 10 to the power minus 3 meter cube. So I can write 10 to the power meter cube per second. Now you can easily calculate. So whether you need time. So I have received an answer. Let's check. So it's option A you are saying. So okay. So let us check whether it is correct or not. So as from this, so I can find V1 easily. So that V1 is Q by A1. So what is Q? Q is 40 into 10 to the power minus 3. What is A1? A1 I can in place of A1 I can write pi by 4 into d square. So what is d area here is 200 mm which is 0.2 square. So if you calculate this thing, you will get 1.27 meter per second. This is V1. Similarly, you can find V2 using Q by A2, right? Same formula, and you will get this as 5.09 meter per second. Okay. So now I have to apply this Bernoulli's equation. Say this is the sorry. So it is in the same line. So from this ground, if I to consider this ground, this Z1 and this Z2 both are equal. Z1 equal to Z2. So from this Bernoulli's equation, I can write P1 by rho G plus V1 square by 2G plus Z1 equal to P2 by rho G plus V2 square by 2G plus Z2. So this Z and this Z will cancel out. So now you can know this P1. P1 is, I have written somewhere P1. P1 is 400 kilo, which is 400 into 10 to the power 3. You just put rho, you know, 1000, G, you know, 9.8, or you can take 10 also, not an issue. V1, you just find out this V1. So accordingly, you can find P2. So just calculate P2. The P2 you will get around 38782 5, near about something like that you will get. So this thing will change because of the value you put. So that means it is near about 388 kilopascal, right? So the correct answer is option A. So that is how you will solve. First you have to use the continuity equation from where you have to find the velocity, and after that, as you are asked to find the pressure, you have, see, remember, in such types of problem where uh, you need to find pressure or velocity, you just remember that either this should be continuity equation or this should be Bernoulli's equation. So put both this equation and solving, you will definitely will get the answer. So in the last we apply this Bernoulli's equation where the initial part and this on the entry part and this exit part, energy at the entry part and energy at the exit part should be equal, or I can say that the total head at the entry part and the total head at the exit should be equal, and accordingly you can calculate and you will get the answer as 388 kilopascal. So I think it is clear to you. Now I am moving to another certain types of question, such types of question. So it's basically about this blood pressure. What is given? The maximum blood pressure in the upper arm of a healthy person is about 120 millimeter mercury. This is the gauge pressure they are giving. So if a vertical tube opens to the atmosphere is connected to the vein in the arm of the person, determine how high the blood will rise in the tube. So blood will rise means it is talking about this device. So you see this device. So basically this device is used to measure the pressure. The total height will determine how much pressure our body is. So that means the pressure of our body and this pressure should be equal, right? So that means what is this? This is the pressure of the mercury. and this is original the pressure of the blood, so that should be equal. So you just show that the both the pressure should be equal and calculate the height the blood will rise. In place of mercury, if there is blood, how much it will rise, so that thing you need to calculate. So both, calculate the pressure of the mercury and the pressure of the blood. Use the formula P is rho GH. I am again giving you 2 minutes time for this one. So please try to solve this one. I think you haven't understand this thing, so I'm just showing you. So basically, as it measures the pressure, so what I said, the whatever may be the pressure of the mercury, the pressure of blood, that should be equal. So what will be the pressure of the mercury? There should be rho of mercury into GH of mercury. So similarly, it should be rho of blood into G into H of blood. What is the rho of mercury? We know that it's 1300 because for water it is 1000 and for mercury it is 1.3 times that of water, the 1000. And G say it is 10. I take it 10 for calculation purpose. And what is given? and age. So the maximum blood pressure is about this much. So this is the maximum blood pressure in a upper arm open human arm. This. So hmm. So that means basically this mercury, how the blood pressure is measured through this mercury. So if in this mercury, this is the height is given as 120 mg, right? Because corresponds to whatever height it is showing, that indicates the rise of this blood. This is corresponds to this rise of the blood, right? So which is 120 mm mercury. So 120 mm mercury means what is the height? The height is only 120 mm. So corresponding, if I convert it into meter, which is 0.1 point this one. And the question is that if the vertical tube, this vertical tube, if it is connected to the vein in the arm, that means it is in atmospheric condition. So that means the for the blood, in that case it will be that thing, rho gh, rho of blood, it is given as 1020, and g is also 10. hb you need to find out from this question. Height, the blood will rise in the tube. So I assume it as hb. So as both are equal, so if I equal it out on both sides, so hb is 130 into 0.12102. This is 1.6 meter. So the correct answer is option D. So I hope that you understand this thing. So I move into the next one. So next is the concept. Next, in the next module, we have studied about various types of equations, streamline, laminar flow, turbulent flow, and all these things. Also, we have studied about the streamline. So the streamline basically is a path that is everywhere tangent to the velocity vector of the flow, right? So a So it's a path that is everywhere tangent to the velocity vector. Okay, so that is the thing. So what is tangent? So I can write the tangent means dy dx, right? So the streamline is a path that is everywhere tangent to the velocity vector of the flow. So if this is x and y, so this tangent, so it is with respect to this velocity vector. That means in the y direction, what is the velocity? That is v and it should be u. So that means corresponding it should be v by u. Sorry, v, it should be u. So you can put this equation, integrate, and you will get the value. So please calculate. I'm just doing another step for you. That is v means here 6x or u means y square. Now this equation is y square dy is 6x dx. So that is the equation we have received. Now integrate and you will tell which will be the answer. I am giving you 2 minutes time for this one. Please solve this one and let me know which one will be the answer. So she has answered option B. Hmm. So now I am integrating this thing. Now if I integrate both this, so I will get this as y cube by 3 is 6x square by 2 plus 6. Is it right? So that means the ultimate equation I am receiving here is y cube. This is if I multiply 9x square plus 3c. So this is the equation. So it is passing through point 1 comma 1. So if I put this value 1 comma 1, so the 3c I get is minus 8. So if I put it here, what I will get y cube is 9x square minus 8. So the equation ultimately coming out is 9. This one is 8. So the correct answer is option B. Yes, you are correct, Shreyash. So I'm moving to the next one. So the concept next is based on your seventh module where we have studied about the dynamic similarity, or I can say this non-dimensional concept what we have studied about this non-dimensional number, Ford number, Reynolds number, Weber number, and all these things we have studied. Please go through this thing. That will definitely some of the important questions will definitely come. So this question is regarding this dynamic similarity in a open channel flow also you can say. So here this is a fraud number. This problem is related to fraud number. So what is fraud number? I think you remember the fraud number is V by root G L or D, whatever you wish you can write. So now you just try to solve if you recall. I'm giving you 1 minute just for this one. And let me know whether you will be able to solve this one or I can summarize this for you. Is anyone? Okay, so I am giving you an hint for this one. Till now, no response. I think I have received. So see, this fraud number I have written. So for dynamic similarity, so what dynamic similarity there should be between the model and the prototype I can write. So that basically is V by, so G is constant. So if I ignore G, because that will be cancelled out from both sides, so that's why I haven't written G, gravity term. Is it clear why I haven't written G? Because that will be getting cancelled out. So what will I'll get? Vm by Vp is root Lm by Lp. So this velocity ratio, so velocity ratio I can write the sorry, this length ratio Lr is Lm by Lp. So the ratio among the model and the prototype is known as Lr, or the length ratio. Similarly for velocity ratio it is Vm by Vp. So that means it is root Lr. So Vm by Vp means I can write Vr. Vr is root Lr. So all the four option velocities having the same thing. So with the velocity we can say anything. Now for discharge. So what basically is discharge? So I can easily write what is a QR. So if in case of QR I can write what is Q, Q into A into V. So I can write AR into VR. VR is this VR. What is AR? AR is area. So area, in place of area is, as the length is given, I can write LR square. Area means what is the unit of area? Length square. So I can write that way. In place of VR I can write root LR. So that means LR 2 and this one is half. That means LR to the power 5 by 2. So the correct option is option D. So the correct answer is option D. Is it clear? Now I am moving to this next one for your simplification. So this question is regarding this pipe flow. So head loss, also this thing is about this head loss. So I'm just giving you a recap. So you remember this Darcy-Weisbach equation. This is for measure loss. What is that equation? HL is FLV square by 2GD. Okay. So please try to recall this thing, or can I solve this one? I'm not solving initially. I will just give you a little bit idea about this question so that you will be easily able to answer this one. So say in a parallel, what is this? Where this equation will be used? This is equation for parallel pipe. So the total head loss. This is parallel pipe, right? the total head loss across each branch. Say this is branch 1, branch 2, branch 3. Because they are connected with the same end and their inlet is same and their outlet is same piping or same junction I can say. So we can use this Darcy-Weisbach equation. So where HL is the head loss, right? Hmm. So this in the parallel flow, the head loss as this thing or the head loss should be same. So whatever may be the head loss here and whatever may be the head loss here, in that case, there should be same. So our objective should be equal or should be balanced. Either if this one is pipe 1 and pipe 2, if I take pipe 1 and pipe 2, you just compare the head loss. As these head loss are equal, you compare other parameters. Similarly, you can also compare pipe 1 or pipe 3 or even pipe 2 and pipe 3, right? You will get the answer, because ultimately at the last your objective is to find the length of the pipe 3. So see in the question what is given. First you need to in this question this length is given, but this length is not given. Okay. So velocity of one first velocity is not given, but the velocity S2 is given. So if I take these two things, what I will get, I will most probably get V1, velocity 1, right? Similarly, if you take pipe 2 or pipe 3 or pipe 1 and pipe 3, you can calculate the length. You just calculate and let me know. I am giving you 3 minutes time for this one. So any response? Okay. So it's the same pipe. Say this three pipe. What is same in this pipe? It is made as this is a pipe having nothing. No information is given about other parameter. Say all only it is given that f and d are same for all these things, right? So f and d are same. G is constant for all these case. So in if I write for this all these three pipe, HL1 should be equal to HL2 be equal to HL3, I can write. So these F, D and G are constant. So what are the variable? L and B are variable. So I can write L1 V1 square is equal to L2 V2 square. This is equal to L3 V3 square. I can write now. So now you take the first two. L1 V1 equal to L2 V2 square. So you have L1 which is 5 meter, V1 you do not have, L2 is 8 meter, V2 is 2 meter. If you put, you can find out from here V1, right? If you calculate V1 from here, so, so you is coming around 2.53 like that. This will be the velocity V1. Now if I take say pipe 1 or 3 you can take, or 2 or 3 you can say I am taking 1 and 3. L1 V1, no, I am taking L2, second one will be better, and L3 V3 cube. L2 you know it's 8 meter, and V2 you know is 2 meter, V3 you know is 3 meter. Then easily you can find this L3. So if you calculate, you will get L3 as 3.55 meter. So the correct answer is option B. Okay, so that is the thing. So now I'm moving to the next, stream function. This is another important concept, stream function. Similar question will definitely be important for your exam point of view. So what is a stream function? It to for a incompressible flow, say for 2D, xy is given, that means it's a 2D. So for a stream function is given, you can find out this u component and v component. What is u component? U component is the partial derivative, sorry, this is the partial derivative of the stream function with respect to y. That means it should be always the opposite. And in case of b, it should be the partial derivative, negative partial derivative with respect to x. So you just now derivate this thing and find u and v. And after that this point are given, so you will get u and v, and after that you have to find the magnitude. That means this thing you have to find out. So you just calculate, and this question need to be solved from your side. I am giving you 2 minutes time for this one. Please solve this one. Yes, I have received an answer. It's B. Yes, correct is option B. So integrating this thing you will get 2x. Sorry, derivative this thing and derivating this thing you will get 2y because here x will be derivative and 2y will come out. And if I put this value 3 comma 4 in place of 3 I will get 6 and where it will get as minus 8. So that means it's 6 square plus 8 square which is 10. Yes, the option B is correct. Good. So I'm moving to the next question. So this is a recap of this Navier-Stokes equation. I am just recapping this Navier-Stokes equation for you. Actually, if I have to write this Navier-Stokes equation, what exactly it is? So this is our Navier-Stokes equation, right? So what is the importance of which term? So basically, this term, this two is our acceleration term. So this indicate local acceleration. This indicate convective acceleration term. So these two in total represent the total acceleration term. Okay, and this is the pressure gradient term, right? And what about the other term? So next is your viscous term. Okay, the next term is your viscous term. Just a minute. This term is your viscous term or the momentum diffusive term, or also known as momentum diffusive term. And this one is the body force, external body force. Sometimes you will find rho g, that means only the body force. So these are the main terms in this Navier-Stokes equation. So now in the question, in context of this Navier-Stokes equation, what does the term del P represent? It is a pressure gradient. So which will be the option? So it is the option C. Okay. So the correct answer is option C. I hope that you understand this thing. So also please recall this equation and each and every term is essential for your exam point of view. So now the last question for this session as the 12th session as the last session has been already discussed yesterday. So I am just elaborating the important topic up to the 11th session and the 12th session already I have discussed yesterday. Okay, so this one will be the last question for today's session. So this is I think that and that will basically help. So the first say what we have studied about the capillary up to this what we have discussed about this capillary and hydrostatic force continuity equation, Bernoulli's equation, pressure head, streamline, Froude number, parallel pipe, stream function, Navier-Stokes and all these things we have already studied. Now this is a problem regarding this boundary layer approximation. So what is been asked, water flow with velocity is given over a smooth plate whose length is this much, so the boundary layer thickness at the end of the plate is what? So that is been asked here. So you have to find the boundary layer thickness. So so if I recall this thing, basically what happens when a fluid flows over a solid surface, a boundary film is formed. A thin region near the wall is there where viscous effects are significant. That means, say, near the wall, the particle of the fluid having velocity almost same that of the wall. So that is a viscous effect is always there. So no slip condition you have studied. Accordingly, no slip condition you have studied. Now in this question, it is not clear whether it's a laminar flow over a flat pipe or any other types of fluid. So for this, I have to calculate this Reynolds number. So, hmm. So see already as it is given. So rho is given, mu is given, u is given, x is given, right? So I just calculate this Reynolds number. What is Reynolds number? Reynolds number is rho v d or x by mu. What is say nu kinematic viscosity is mu by rho. So this formula comes. So here v is represent not v velocity is represented by u. So we just put this value and we will get this much. So what we know? We know that if the Reynolds number is less than this number, then this flow is laminar. So that's why we use the corresponding formula where this is 5x by root over Reynolds number. So you just put the value and we'll get this as the answer. So up to this it is clear. So say if this value is more than 5 into 10 to the power, that means turbulent. For turbulent, what is the formula? Plus also remember this thing. That formula is 0. There are so many formula for this one, but the mostly used formula is minus 1 by 5. Apart from these 2 to 3 formulas are there, but this one is the most commonly used formula for turbulent one. That means Reynolds number should be greater than 5 into 10 to the power 5. Okay, that thing. Now this, so I am also showing this last class notes. So where in the last class we have discussed about the open channel flow, where in this open channel flow some numerical we have studied. So this is regarding a problem related to this open channel flow, right? So hydraulic jump also I have discussed. Say this is a gate. If the gate is suddenly open for this ocean, so what will happen? Sometimes the liquid is coming like that way. Okay. So this is fully liquid. So certain critical depth is there. So initially this is a before the jump there is a certain height and after the jump there is a certain height. Okay, so various types of depth are there. This is y1 or y2 I represent this depth. So the in the question, the flow depth after the jump is been asked to find out. So the jump, before the jump, the length is given, velocity is given. So accordingly, as this velocity, you can calculate the float number, right? So that means this thing, you can also directly the formula, if you, this formula basically is this one. Okay. So here I can calculate the float number. Float number is V1 by 2 GY1. So accordingly, the V1 I know this is 9. This is 9.81 into 2. So that means 2.03. So if I just put this value here, I will get this value as around 2.415, right? So what is y1? Y1 is given as 2, right? So that means if I multiply it into 2, what I will get 4.83. So the correct option is this one. So please go through the previous lecture also, that will help you to clarify all this concept, right? So up to this is for today's session. I hope that you people have followed this session carefully, and if you are having any problem, feel free to mail me. I will help you to solve this for you. So I am also sharing the mail ID in the chat box for you, and all the previous notes has been shared with you earlier. The rate ATP. So up to this, so please look into this thing, and if you are having any confusion, mail to me, and I hope that you all, hope you enjoy this session. It's it's a good lesson, for it's a good experience for me to have taken this NPTEL course, and I really enjoy this, and I hope that you people have also get some knowledge at least. So give your valuable feedback, because your feedback is quite vital for me to improve. Okay. So anyway, all the best for the exam. So just follow the fundamental basics and all these things. You will definitely score good marks in the exam. Till then, try your best and have a good day. And happy Diwali in advance. Okay. We will wind up today's class. This is the last session. Okay. Bye.